All right, we've been through simple series circuits and parallel circuits, so now we're going to work on compound circuits. All right, just a quick review. The circuit on the left just has one path for electrons to flow through, so that is a series circuit. The second circuit, the one on the right, has more than one path. This one has two, but it could have, 3, 4, multiple paths. As long as there's more than one path for the current to flow through, then it is a parallel circuit. So the circuit on the left, we can use Ohm's law to solve for just about any of those components. If we're given two, we can find the third one. Now the one on the right, this is where we use the 1 over RT equals 1 over R1 plus 1 over R2 to get our total resistance. Now with the series circuit, it doesn't matter how many resistors we add in there. As long as there's just one path for the current to flow, then it's still a series circuit. All right, if we look at the parallel circuit, here this is still a parallel circuit. It's not a compound circuit because these two resistors are in series. Okay, so there's still just the two paths for the electrons to flow. All right, now if we take a look at this one, we've got the parallel circuit, but then we also have another parallel circuit inside there. So now I've got 3, 4 paths for current to flow. But these two paths are inside of one of the circuits. So we could have 4 paths going out where they're all parallel, but here we've got a parallel circuit inside of a parallel circuit. All right, to find our total resistance, we're going to start with that parallel circuit that's inside the circuit. We're going to start with the R3 and R4. We're going to combine those using the formula for finding total resistance of parallel resistors. So I'm going to call this RT1 because this is my first total resistance. This isn't the total resistance for the circuit. So it's going to be 1 over 300 plus 1 over 500, which comes out to approximately 187.5. Now remember, with your calculator, this is where you'll enter 1 divided by 300 plus 1 divided by 500. Hit enter, you get that total. Then you use the x to the negative 1 or the 1 over x button, depending on what type of calculator you use. All right, so now I can look at that parallel, those two parallel resistors as one resistor with a total resistance of 187.5. It's in series with R2. And we're getting total resistance of resistors that are in series. We just add them together. So I'll take this RT1 plus my R2. When I add 187.5 ohms plus the 600 ohms, I get 787.5 ohms. And so now that's just like having one resistor in this branch that has 787.5 ohms of resistance. Now we're going to use the formula for parallel resistors again, since these two are in parallel. So I've got 1 over R1 plus 1 over my RT2. Then I put that in my calculator to solve. We end up with approximately 265 ohms of resistance. All right, so let's look at another one. All right, so here I've got my total current, and I want to find my voltage for the circuit. Okay. I don't know how much current is going through each branch individually. So I'm going to have to find my total resistance. Then I'll use Ohm's law to find the voltage. Now that R1, we've got the K there. And also with the R2 and R4. That K just means 1,000. Okay, so that R1 is 3,000 ohms. Right. So with my R3 and R4, I want to solve this circuit first. So I've got 1 divided by 800 plus 1 divided by 1,500. Then I take the inverse of that by using the x to the negative 1, or the 1 over x button. And I just rounded off to the nearest ohm, so it's approximately 22 ohms. So now I can look at those two as just one resistor of 522 ohms. Now my RT1 and R2 are in series, so I just add those together to get the total resistance for that branch of the circuit. So when I have my 522 ohms plus my 2,500 ohms, I get 3,022 ohms of resistance for that branch of the parallel circuit. All right. So now it's kind of like having, well, it's exactly like having a parallel circuit with two resistors. I've got my R1 and my RT2. So I use my formula for finding total resistance. So I'll have 1 divided by 3,000 plus 1 divided by 3,022. And I get approximately 1,505 ohms. That's rounded to the nearest ohm. All right, so now I can use Ohm's law. And I should have just deleted this branch. Sorry, I didn't do that. But my total resistance is 1,505 ohms. So I'll multiply my total current times my total resistance, 0.02 amps times 1,505 ohms, and I get 30.1 volts. All right, now we're going to work through one more. Okay, here we have 6 resistors, and we have multiple paths for the current to flow through. We're going to start out here with R4 and R5. I'm going to combine those to make one resistor. So I use the formula RT equal 1 over RT equals 1 over each resistor. And again, I'm going to call this RT1 because this is my first total resistance, but it's not the total resistance for the circuit. So I've got 1.5K, which is 1,500 ohms. My R5 is 425 ohms. When I solve that, I get approximately 331.2 ohms. So now I can combine those two into one resistor. Now we're going to add my R3, my RT1, and R6 because those are all in series with each other. Okay, there's just one path that goes through all 3 of those. So when I add my 300 plus 331.2 plus 650, I get 981.2 ohms. Right? I've still got more than one path to go through. On this one, I'm going to need to combine these two resistors first, because this resistor is in series with this one, but we have to solve the parallel circuit first. Okay, so I'm going to take my 1 over RT3, and I'm just calling this my third total resistance. It's not the total resistance for the circuit. Equals 1 over my RT2 plus 1 over R2. Now when I solve these, I'm going to take 1 divided by 981.2 plus 1 divided by 220. Then we take the inverse of that, and we get approximately 180 ohms. And remember, with parallel circuits, with parallel resistors, our total resistance will be lower than our smallest resistor. So I know it has to be less than 220 ohms. All right, so my RT3 is 180 ohms. All right. Now I've got these two resistors that are in series with each other, so we just add them together. I'm going to take my RT3 plus R1. So I've got 180 ohms plus 1,000 ohms, which equals 1,180 ohms. So now that I've got my total resistance, I can use Ohm's law. I'm looking for the E, the voltage, so I cover up the E. It's I times R. Now that 21 milliamps is not the same as 21 amps, so we don't want to multiply 21 times 1,180. We have to move that decimal place 3 places to the left. So that's going to be 0.021 amps times 1,180 ohms, which comes out to 24.8 volts. And that's kind of an introduction to compound circuits.